Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 18, 2025, which was about 3 days ago. The big contribution is a method that internalizes self-consistency using multi-agent debate, delivering gains like plus 27.6 percentage points self-consistency on GSM-8K and plus 22.4% pass at 20 on MATH. The paper is titled Internalizing Self-Consistency in Language Models, Multi-Agent Consensus Alignment, and the implications for model training are quite significant. In short, the approach uses debate to create consensus-aligned preferences, then post-trains models to favor decisive, accurate, and concise reasoning that generalizes beyond math to common sense and science tasks. On X, reactions frame consensus alignment as obvious yet useful, with one thread debating reinforcement learning efficiency and another highlighting label-free debate signals. Engagement looks moderate, with dozens of likes. Reactions had focused on label-free signals, and that set the stage for how the method operates. Figure 1 presents the full pipeline. Cloned agents debate, which yields majority and minority reasoning traces, and those traces become self-generated preference data. MVSFT imitates majority trajectories, MVGRPO rewards agreement with consensus, and MVDPO and MVKTO learns separation using both sides, so every token in the chain contributes to the preference. The updated policy then supports single-agent or multi-agent inference. Figure 1 laid out the pipeline. Figure 2 shows what that buys in practice. The 3 panels plot sampling consistency versus the number of sampled reasoning paths, contrasting the base model in orange with the post-trained policy in blue. Consistency stays markedly higher for the post-trained policy across MathQA, MATH, and GSM-8K, which means more trajectories agree on the same answer. The first point also rises, because more responses produce parsable answers within the token cap. So the previous figure, contrasted pipelines, figure 3 shows what the gains look like across sampling budgets. The 3 panels plot accuracy versus the number of sampled reasoning paths, and the blue post-trained curves sit above the orange base curves throughout. Dashed pass at T rises, solid majority vote at T rises, and even the dotted greedy line shifts up, which means higher ceilings and better single-shot answers. The pattern holds on MathQA, MATH, and GSM-8K, so extra samples compound the benefit rather than replace it. Alright, the previous figure showed rising accuracy with more samples. Table 1 summarizes single-agent, zero-shot accuracy, which matters because it reflects gains without ensembling. The table lists 4 models across 3 datasets, comparing a base column against MVSFT and 3 consensus-aligned objectives. MVDPO generally leads, with big jumps like plus 22.7 on GSM 8K for QN2B and plus 23.1 on MATH for Llama 8B. MVKTO sometimes wins on smaller models, while scalar reward, MVGRPO trails. Okay, the previous table highlighted single-agent boosts. Table 2 expands to multi-agent debate accuracy. The table reports majority vote after debate across models and datasets, comparing debate baselines and MVSFT against 3 reinforcement learning objectives. MVKTO tends to win on smaller models like QN2B, while MVDPO leads on larger ones like Llama 8B, which signals that learning pairwise trajectory separation scales well. The biggest jump shows on Llama 3 BMathQA, rising by 42.73 points, which underscores that debate-derived preferences reliably lift ensemble consensus. Alright, 2 takeaways stand out. Internalizing self-consistency through multi-agent consensus makes models decisively pick stable reasoning paths, and the debate-derived preferences deliver large accuracy gains with no external labels. The broader implication is practical. Post-training can turn ensemble tricks into built-in reliability across tasks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.